Okay, this is where we were yesterday. We were on number 7. There's 2 ways to do this, and I'll show you both ways. Okay, so this is a good way to enter into the fact that you have a potential energy up here, let's say, between the paper and the marker, correct? Based on mgh, the mass of the marker, the acceleration due to gravity, and the height, correct? If it falls, it's converted to kinetic energy by way of 1/2 mv squared. I measure the velocity, or I can determine the velocity, correct? Yes? Okay. So you can equate potential energy lost with kinetic energy gain. All right, let's read the problem. It says, Brittany is changing the tire of her car on a steep hill 20 meters high. She trips and drops the 10-kilogram tire, spare tire, which rolls down the hill with an initial speed of 2 meters per second. What is the speed of the tire at the top of the next hill, which is 5 meters high? So what is the total distance that the tire is traveling? What's the total distance that the tire is traveling? Now you have to think potential energy. What distance is the tire traveling? Anybody? No one? Thursday morning? What distance is the tire traveling? It's on a 20-meter hill, and then it's going down to a 5-meter hill. So it's going to drop, correct? Here's a level surface, and here's the first hill, and here's the second hill. That's way too big. Okay? This is 20 meters. This is 5 meters. That's the height of that hill, and that's the height of that hill. So, in terms of potential energy, the energy that it's getting, it's up here, isn't it? mgh, isn't it? Isn't that where it's getting its energy? And then it's going to end up down here. So what distance is it dropping to give up the potential energy? – 15 meters, correct? So the distance is 15 meters. Okay? What is the initial velocity of the tire? The mass is 5. I'm sorry, the mass is 10. The initial velocity is 2 meters per second, correct? The initial hill is going to be 20. Final hill is going to be 5. What else is given there? Is that it? Okay. So the final velocity is going to be what we're looking for. That's the initial velocity. Correct? What equation utilizes, we have G, which is 10 meters per second squared. So we have initial velocity, we have final velocity, we have distance, and we have acceleration. What equation utilizes those 3 quantities, those 4 quantities? Well, we looked at it yesterday, correct? It's going to be Vf squared equals V naught squared plus 2AD. So Vf equals V naught squared plus 2 GD. Correct? So plug this in. Let's plug in the values. So this is going to be VF equals 2 squared plus 2 times 10. And what is the distance? Anybody? What's the distance? 15. Very good. The distance is 15. And what do you get? Anybody? 17.4 meters per second. Correct? Now, let's look at it a different way. We know this is a great equation to use. It's very popular. Remember, you need to have the four variables in the equation somewhere. Either you're looking for it or you're given constants. Okay, you're given the values. All right, so can I erase this here? Are you finished writing that down? Remember, I'm filming this. Okay, so let's look over here. We know that the change in potential energy is going to equal a change in kinetic energy, correct? That's where it's getting it from. Yes or no? Right? Okay? So I need some room. All right, so if that's true, I can say mgh equals 1/2 mv squared. Correct? Yes? I can say that, correct? Yeah. So the masses cancel. It's the same mass, the tire. We're using the tire before and after. So I know that G, this is going to be the change in height, correct? It's going to be 20 minus 5. It's not vector. It's just a difference in height. And that's going to be equal to 1/2. And that's going to be final minus initial because it's a vector. Correct? So I'm going to multiply both sides by 2. And that's going to equal V final squared minus V naught squared. And then I'm going to add this to both sides. V naught squared plus that and take the square root. Correct? And I can get rid of that, and I can get rid of that. It goes to 1. Correct? Is that the same equation? So the equation I just derived here is going to be V naught squared plus 2GH, correct? Or let's say delta H, correct? Isn't this the same as what I applied here? Isn't it? Yeah, I just simply wanted to show you the relationship between potential energy and kinetic energy. Okay? Easy? Are we done? Isis, you okay with that? All right. I don't want to make this film too long. It's already 9 minutes.